Hello, good Wednesday morning. I am so excited to be back today. It's been an amazing week here in Phoenix. We are in the triple digits, so that's summer here. My name is Mai Ling Chan, and I am with Cognixion, and I am really, really excited to be bringing on Sarah Pearce. She is our senior brain-computer interface software engineer, and she is going to be sharing with us her journey into what she's been doing with the brain computer interface and augmented reality and our plans for cognition for the future in AAC. So without further ado, let's bring on Sarah. Good morning, Sarah.
Good morning. Hi, everyone.
Hello. And where are you hailing from?
Right now, I'm tuning in from Toronto.
Nice.
In Canada.
Wonderful. What's the weather there?
It's a beautiful, perfect day, not a cloud in the sky, nice and sunny.
Nice.
But unfortunately, I'm inside working today, but maybe later I'll take some time to go for a walk.
Excellent. And this is part of our series of kind of pulling back the curtain and sharing the behind the scenes. Our amazing, we're calling you guys like brainiacs, coders, people who are helping to bring AAC into the future. And our whole team is in Toronto. How many people are there with you?
We have we have about 6 people at the moment. Some really talented developers, the finest in all the land.
But of course, yes. And we did have Chris on a couple of weeks ago, and he talked about some amazing work that he's done with fetuses with BCI, just incredible. And I have been really looking forward to our talk today to find out about your journey and how you got involved in this space. So that's a great place to start. Can you tell us a little bit about, you have such an interesting background of how you got started. Yes.
So I am the second youngest of a great big family. My older brother has cerebral palsy, and my younger brother was diagnosed with moderate to severe autism when he was very young. And this is important because he was nonverbal until he was about 7 to 8 years old.
Wow.
So, as a result, I've always been, relatively aware of some of the challenges that families have with regards to AAC needs.
Mm-hmm.
To get a little bit more into the professional background I come from, I originally went to school for a very interdisciplinary degree with a really heavy focus on UX, user experience design. And that was really worthwhile and really, really enjoyable for me. But I realized that by the end of my undergrad, I wanted a more technical perspective to apply these design and collaborative skills to. So the summer after I had graduated from school, I ended up working at a biomedical company that was making a medical device as part of this big, it's called an X Prize competition.
Oh.
And as part of that, I was doing a lot of design and really cool work on these medical devices. And that really solidified for me, this is the kind of space that I want to apply these skills to. Mm-hmm. I was doing mostly the user experience work on that team, but I really wanted to learn the more technical parts. So as a result of that, I went and got my master's in biomedical systems design engineering.
Wow. Okay, let me ask you one thing. Yes, it sure is. When you're talking about UX and user experience, can you explain that? Because that's really important on your continuum of where you are now.
Right. So design is a big umbrella term, and it can mean a whole lot of things. For me, the kinds of problems I was really interested in solving as a user experience designer was how does having a product and the way it looks is fine and dandy, but the real impact that something will have on a user, someone who's using a product, is what are the challenges and problems? What are they feeling when they're actually interacting with these kinds of products? And there's a whole bunch of ways you can interface with something. You can hold it in your hand. You can type buttons on a smartphone. So it's a pretty wide umbrella. But I was always really interested in not just on how something looked, but how did users that use the things that I was working on feel frustrated. So one of my favorite examples I love to give is when someone came in through and they said, Sarah, as part of our medical process, we need someone to do a finger pricking test. But we couldn't get anyone to actually go through with it because, getting their finger pricked and get the blood work done is really scary. And honestly, I can't blame them. I'm the exact same way. And they said, how can we improve this experience to convince people to want to prick their finger? And After, I took a step at it and I, did some research and I looked around and I realized we're never going to give someone a good experience for wanting to prick their finger. So let's go the other way and make the experience so bad that they have no choice but to prick their finger and go through. And those were always the kinds of
Wow.
problems I thought were really interesting.
Yeah.
Um,
That's
but
amazing. And so did many people go for it?
yeah, actually we had way more success. And it doesn't feel good in the moment, but when the person who was actually using our product actually got their medical results, that was really satisfying and it was well worth the effort from their opinion. So it
Right.
was
That
very
makes so much sense.
rewarding.
Amazing. Okay. So now you go back for your master's.
Right. So my degree that I had gotten focused on biomedical signal processing and machine learning. So what we were trying to do for my research was, using artificial intelligence and these non-invasive brain signals to decode intentions that a person was trying to do. So my specialty was non-invasive, so we never poked or prodded any people. It was just stickers or little things that would just rest on the scalp, so we were not zapping anyone.
Right.
And my specialty in that area was in neurorehabilitation and autism research.
Mm,
Um,
that
so
makes sense.
right, so for my personal interest was like autism research because like I come from a family where I've seen a lot of those needs. So,
Yep.
how can we rebuild damaged parts of the brain, or how can we use brain computer interfaces to help people to interact with the world around them better?
Mm-hmm.
So along with the autism, I also dabbled in stroke rehab. So
Mm,
people that
yep.
had strokes and lost control of particular limbs, how could we actually use brain computer interfaces to reteach them how to move their arms or their legs, etc. again?
Right.
So you know that was really cool and really rewarding, and academia was so interesting in like the kinds of equipment that we dealt with. It was just like nothing I had ever seen before. But during my time, I was rather frustrated by the academic siloing and the non-collaborative environment that academia kind of fosters.
Mm-hmm.
Because I had this user-centered, user experience design approach to solving problems that I was interested in, I was always really frustrated with how detached the problem finding and solving process was from the actual people we were supposed to be helping.
Right. Right.
And ultimately, I decided that research was very nice and very cool, but it wasn't the kind of problems I wanted to solve.
Mm-hmm.
So ultimately, I moved into the industry, and now I work for Cognixion as a senior BCI software engineer.
Excellent. That's brilliant. It's wonderful. Okay, so let's go to the question that I typically ask is, what's new in AAC? And you and I spoke before this because I know that you have some experience with your brother, and then you have been working in this area for so long. So what would you say you've been like kind of focusing on in the area and in the area of newness?
So there's two things I would love to touch on what's new for AAC. The first one I would love to speak a little bit to is this transition to immersive technologies for AAC. We all know how amazing smartphones and tablets have been and how much they've changed the AAC industry. From my perspective, what we've really gained in this like digital space, we've kind of lost in the social space. So, for example, everyone is complaining how people are so involved and engrossed in their phones that they don't pay attention to the world around them. And I think that's kind of similar to AAC. A big piece of what it means to communicate with someone else is not just about the thing you want to say, the speech you want to have said. It's about body language.
Right.
It's about making that human connection. And I think that's a huge challenge that AAC devices are having now to foster that kind of communication. And as a result, a lot of the natural aspects of communication kind of get lost in the mix.
Yep.
Now we're at a point in technology where we have these things like virtual and augmented reality environments, and they largely stayed in the land of research because they just had all these complex computing needs. And now that it's here, we all have something in our pocket that can actually run these kinds of environments. Now the issue becomes, how do we make that kind of technology accessible? How do we actually let people use these things to communicate with people around them?
Right.
And as a result, I'm seeing this trend with a lot of companies trying to move away from facing your phone and tablet? How do you create these portable and wearable devices that give this really immersive experience that blends this digital layer with the actual environment of the individual that they would have been otherwise separated from? And in my opinion, augmented reality is a big game changer because it allows people to do things like make eye contact and see what's going around them while they're communicating. And you don't have to stop what you're doing and look at your phone to access the eye tracking technology to prepare a response. It's more intuitive, and that's something that I'm really excited about.
I love that. And just to expand on augmented reality for people, because I sometimes got confused too of the AR and the VR. So a couple weeks ago, I had Chris Bugay on and I showed everyone the Oculus, and that was virtual reality, like really trying to submerge you in something that's 3D and feeling like you're there as much as possible. The augmented is this, like you had said, a layer and just changing kind of the 2D spectrum, correct?
Yeah, it's for me, the best way that I like to explain the difference between virtual and augmented reality is virtual reality. Anything that's actually around you in the physical space is kind of like disappeared. They're sort of put into this new space, and there's new walls and there's new objects to interact with. But in augmented reality, you can actually still see what's going on in your environment around you. If someone has walked in from another room and has started speaking, you still get those context clues that someone has entered the room because you can see them and you can hear them, and it's not virtual little beeps and boops that are coming into your ear. So it's still very immersive in a way that lets you explore, your space that's around you.
Excellent. This is a good time to bring up Lucas Stuber's question. So he is the product development director for Cognixion, and his question is, given your extensive background in UX, which is the user interface, in addition to the technical skills, I'm curious, what unique design opportunities do you think BCI, which is brain-computer interface and augmented reality speech generating device, presents versus a tablet solution in terms of the lived experience of the users?
I'm so glad you asked that question.
That really long question, Lucas. We love it.
So let me speak a little bit to why using brain-computer interfaces in AR is a good fit for AAC problems. So there are a lot of people that would really benefit from AAC, but don't actually have the ability to access that kind of technology. BCI's is a highly technical, very specific kind of technology that largely benefits a niche set of users who have no other option right now. So, for example, using something like BCI control for an AAC device is really relevant for users with progressive disorders such as ALS. These individuals need a lot of support from their circle of care, and their ability to communicate using existing AAC devices become more difficult over time. And at late stage ALS, you effectively become locked in your own body. And even though you have this capability of understanding and having desires to communicate complex needs, your brain is unable to communicate with your muscles to demonstrate those needs via speaking or typing or eye tracking software. With BCI, what you can do is you can capture those intentions straight from the brain and use those signals to control the AAC device, which kind of circumvents the part that's degrading while still being able to express these needs and desires. So how does AR and BCI relate to AAC? To answer your question directly, it means that someone with using these two technologies, it means that someone with ALS who is completely locked in and at the end of their life can use BCI as a control method. Right now, there's nothing for them. And it means that that individual can make eye contact with their loved one and be able to say, hey, I have to go now and I love you. And that's so powerful. Sorry.
I know your passion and everything. And thank you.
Okay, I'm good.
Thank you. That's why we're here.
Yeah.
Thank you,
Absolutely.
Sarah. Oh, okay. It's not a Facebook Live unless Mae's crying.
Oh, I'm so sorry.
Woo. All right. Let's go to what's next. This is the space that we are in and what you're working on. And you kind of laid the landing strip for us there. So, so what are you up to at Cognixion, Sarah?
What am I up to at Cognixion? I'm up at a lot of things. I can't speak to every little project I'm working on because, I have my hands in a lot of little honeypots right now. I'm a very busy person. One of the problems that I'm personally really interested in working and have been very involved in is looking towards how the future will look at not just alternative augmented communication, but alternative augmented control. People want to do more than just talk. Simple as that. And I think that absolutely, we should be actively working towards providing that kind of capability to everyone. So, right now, you and I have all these different ways of being able to control our environment. We have these voice assistants, we have smartphones with all these apps and buttons. But these kinds of things are really difficult to use for people who are non-speaking. These assistants assume that you can talk to it and that there's an actual thing that's listening in the room. And what kind of problems arise with being able to do this control when you have someone who can't speak? And that's a really interesting problem for me personally. Right now, any AAC user that wants to try to use them has to basically duplicate like a bunch of things they want to say and add like the "Hey Alexa" or "Hey Google" or "Hey Siri," and basically hope that their volume is loud enough that the device in the room is going to be able to pick up on it. And, how do we allow these widely accepted and widely used communication channels to allow people who are, for these individuals who are locked in, to be able to have that same type of control in their own lives? And that's where, my work in BCI starts to, focus on that communication and control aspect. Now, it is within a constrained environment, but, when we're talking about control in the context of not just like a virtual like reality environment or like fake objects that someone can interact with, it's a game changer because BCI hasn't really taken the grounds to do control in the context of a real physical object that people can see, smell, touch, hear, all of those things. Right. And it's a really big challenge for, BCI development because there are potentially an infinite number of ways to control stuff in your house. It's not just how many things are in the house, but, if you think about those fancy smart RGB lights, and it's like there's an infinite number of colors you could ask that thing to change to. So it doesn't become, are these yes or no desires? Is this on or off? It becomes like, how do we use artificial intelligence in the signal processing to support that kind of control? And, how can we predict the kinds of ways, and how you prefer to control those devices in your own smart home and those devices around you? How can we make it fast? How can we make it precise? How can we make it comfortable enough to allow people to do these things at their best pace possible? And solving that kind of problem is important to me because, communication is so empowering, but control provides independence. And that's something that I think all BCI researchers and all the engineers and, software people are really trying to work towards in this AAC space.
Beautiful. And that's something that we haven't put together. I'm actually going to bring on Andreas Forslund is our CEO and a co-founder of Cognixion and definitely a visionary in this space. And he says AAC can move beyond just communication to communication and control. And that is what we are all working on together here at Cognixion. We work with the disability community and we use these words like marginalized, right? And so when you're talking about these smart speakers, the Google Home, the Alexa, it sounds wonderful that you can just say, Alexa, tell me a joke, make the fart sound, like all of these things. But you have to say that out loud, right? So using the AAC to be able to do that, and then now that speaker reacts and does what you want, responds to a command, and like you're saying, controls the lights, can open doors, all of these things. That's where these two pieces come together. And the space that you are in, Sarah, helping us to use the brain versus having to use upper extremities or even muscle movements. I mean, there are so many options already. So moving to the brain-computer interface space and augmented reality is where we're going. I am so proud of our team. Thank you so much, Sarah, for coming on and being a part of this with us and sharing with everyone what we are up to. So
thank you so much for inviting me and having me here. It was a pleasure to speak with you.
Thank you. Okay, bye-bye.
Bye, guys.
All right. Wow. Well, that was an incredible one today. I hope that you guys enjoyed it as much as I did. I'm always surprised and amazed by the people on my team, and I'm just blessed that they're willing to come on and share with me like this and with you. So I just want to let you know that today's AAC What's New, What's Next episode has been brought to you by the Speak Pros app, which is created by the team at Cognixion. It offers an intuitive interface that allows people to express themselves using swipes, taps, and eye tracking technology. You can find out more at speakpros.com or contact me directly for a demo and to get professional access to SpeakPros. Thanks for joining us, and I'll see you next week.